Hello everyone, assalamu alaikum. Today I am going to discuss with you some problems from calculus. Here, first I discuss with you what is calculus actually. And calculus is the mathematical study of continuous change. This branch of mathematics focused on the study of change and motion. And what is the two branches of calculus in mathematics, differential calculus and integral calculus. Today I am going to show you some problems from differential calculus. What is differential calculus? This area deals with finding the derivative of a function, which measures how a function changes as its input changes. The derivative represents the slope of the function at any given point, allowing us to understand the rates of change such as velocity in physics. Okay, now what is now first problem. Here we are given two scenario. First is g of x is sin x, second x is equal to 10 root over twice y. We have to find the derivative of log x with respect to x. Also we have to find the extreme value of this in this interval according to scenario 1. Then we have to find the prove that this, we have to prove this according to scenario 2. Now first we have to find the derivative of this. When we find the derivative, we can log this function. We can write this function by ln a by ln x. We can keep ln a outside of derivative. Then we have ln x inverse 1. We can differentiate it. We get minus 1 ln x to the power minus 2. Then we get ln a by ln x whole square times 1 by x. When we differentiate this ln x 1 by x. Now we are going to find the extreme value of part B in part B. Okay, in part B, f of x is equal to 1 plus twice g of x plus 3 times 1 minus g of x whole square. Here we have to substitute the value of g of x, which is sin x, plus 3 times cos square x. If we differentiate it, we get f prime x is equal to 2 cos x, because differentiation, if we differentiate 1, it's a constant, we get a 0. So here we get 2 cos x minus 6 cos x. Again we differentiate cos x, then we get sin x. Okay, so 6 cos x minus sin x, that means minus 6 cos x sin x. Okay, we do this differentiation by this process. Now we get a minus 2 sin x minus 6 cos square x plus 6 sin square x. For maximum and minimum value, we know f prime x is equal to 0. So f prime x, from f prime x is equal to 0, we get cos x equal to 0, or 2 minus sin x is equal to 0, which implies sin x equal to 1 by 3. Now if cos x is equal to 0, then we know sin x is equal to root over 1 minus cos square x, which is 1. So if second derivative of f of x is minus 2 times 1 minus 6 times 0 plus 6 times 1 square is equal to 4, which is greater than 0. So for x is equal, cos x is equal to 0, the function exists minimum value, and minimum value is 1 plus 2 times 1 plus 3 times 0 is equal to 3. That means for cos x equal to 0, we get if the second derivative of second derivative of f of x is greater than 0. When it is greater than 0, we get minimum value, and the minimum value is 3. Again, if sin x equal to 1 by 3, then cos square x equal to 1 minus sin square x, which is 8 by 9. And then if sin x equal to 1 by 3, we get the second derivative of function. Second derivative of the given function is minus 16 by 3, and since it is less than 0, we will get a maximum value for this value. So maximum value is 1 plus 2 times 1 by 3 plus 3 times 8 by 9, which is 13 by 3. So maximum value is 13 by 3, minimum is 3. Now I'm going to show you some problems. Third part, Our third part was to prove this from x equal to 10 root over twice y. Okay, so we are given this. From here we get root over twice y equal to 10 inverse x. We can write twice y equal to 10 inverse x whole square. If we differentiate with respect to x, then we get 2y1 is equal to 2 10 inverse x times, again if we differentiate 10 inverse x, we get 1 by 1 plus x square. If we multiply 1 plus x square in both sides, then we get y1 times 1 plus x square is equal to 10 inverse x. We can cancel 2 from both sides. Again, if we differentiating again this equation with respect to x, we get y1 times 2x plus 1 plus x square times y2 is equal to 1 by x1 1 by 1 plus x square. If we differentiate this term, we get 1 by 1 plus x square. And if we multiply 1 by x square by both sides, we get 2 times 1 by x square times xy1 plus 1 plus x square whole square times y2 is equal to 1. So this is a required expression we have to prove from this given expression. Now going for our second problem, which is our second problem. This is our second problem. We are given two functions. First we have to find the value of this, then we have to obtain the differential coefficient of function f of x with the help of limit. Also we have to prove that sum of intercepts out of from the axis of coordinates by any tangent of the curve is a constant. We have to show this. Okay, now from part A, we are given this. We can write this x to the power 3 by 2. We can write this root over x whole cube. We can write this also root over a whole cube. Then we have a formula. From here we can write 3a to the power 3 root over a to the power minus 1. Our formula is here. Here the formula I used, limit x tends to a x to the power n minus x to the a to the power n. If we are that, then we can write na to the power minus 1. So we used this formula here. Okay, 3 na to the power n minus 1. Now second part B. In part B we are given this function f of x equal to a to the power 5x. We can write f of x plus h is equal to a to the power 5x plus 5h. We can write this a to the power 5x times a to the power 5h. From the definition of derivative, we can write differentiate. If we differentiate f of x, we get limit h tends to 0, f of x plus h minus f of x divided by h. If we substitute this value, we get a to the power 5x times a to the power 5h minus a to the 5x. If we take a to the power 5x outside, keep this outside bracket, then we get a to the power 5x by h times a to the power 5h minus 1. If we here 1 by h this if we apply if we expand this term, a to the power 5x times limit h tends to 0 1 by h. If we expand this term, we get 1 plus 5h by 1 factorial times ln a 5 square h square by 2 factorial times ln a whole square 5 cube h cube by 3 factorial ln a whole cube. Okay, then when we if we multiply this 1 by h by each of this term, first we have to cancel this 1 and minus 1. Okay, then we have to multiply by each of this term by 1 by h. Then we get from the first term we get remaining is only 5 ln a. Then if since h tends to 0, this all this term will be 0, and the remaining part is a to the power 5x 5 ln a. Okay, this is our answer. Okay, now third part. In third part we are given g of x equal to 0. First we have to find the dy by dx here from this expression. If we differentiate on both sides on equation 1, we get 1 by 2 root over x plus 1 by 2 root over y dy by dx is equal to 0. From here we get dy by dx is equal to minus x to the power minus half divided by y to the power minus half. If hk is any point lies on the given curve 1, then we get root over h plus root over k is equal to twice a. This is equation 2. Okay, at the point hk we get dy by dx is equal to this. Okay, at this point we get this, the value of dy by dx is this value. Okay, equation of tangent at the point hk is the equation of tangent equation of tangent y minus y1 dy by dx at x1 y1 x times x minus x1. Okay, we use this formula here, equation of tangent. Now this is our equation. Length of intercept of x-axis will be root over h times root over twice a, and length of intercept of y-axis is root over k times root over twice a. Sum of the intercept of both axes will be this. We have to add these two terms, then we get root over twice a times root over twice a, which is twice a only, which is the constant. Okay, proved. Okay, now third problem is we are given this expression. First problem, the volume of a rounder balloon increases at the rate of 10 cubic centimeter. We have to find the rate of change of its surface when the radius is 15 centimeter. From the stem we have to show that d square y by dx square plus 6a divided by x plus twice y whole cube is equal to 0. If a equal to 7, then we have to find the equation of the tangent and normal at the point, so to the curve of the stem. Okay, let r be the radius and a be the area and v be the volume of a rounder balloon at any time. So area is a is equal to 4 pi r square. We know the surface area of the circle is 4 pi r square, and volume is 4 by 3 pi r cube. Surface area of a balloon and volume of a balloon. So if we differentiate this term, we get a d by we were given that d by dt is equal to 10 cubic centimeter, because volume of a rounder balloon increases at the rate of 10 cubic centimeter. Okay, so d by dt is 10 cubic centimeter. And if we if we differentiate this term with respect to with respect to t, then we get dv by dt is equal to 12 by 3 pi r square dr by dt, because this becomes 3 when we differentiate this term. This becomes dr by dt 3r square dr by dt. Okay, then we find the dr by dt here, which is 10 times. We substitute the value of dv by dt here, we get a dr by dt is equal to 1 by 1990 pi. Okay, now part B. In part A is still not finished. Now we are given a is equal to 4 pi r square, the rate of change of its surface. If we differentiate this with respect to r, dA by dt is equal to 8 pi r times dr by dt. So dA by dt is 8 by 6, which is 4 by 3 square centimeter. Okay, now part B, we are given this expression. We have to differentiate both sides with respect to x. So we get 2x times x dy by dx plus y plus 2y dy by dx is equal to 0. So we get dy by dx is equal to minus 2x plus y divided by x plus 2y. Again, if we differentiate both sides with respect to x, we get this. If we differentiate d square y by dx square, we use this formula d dx of u by v v square v du by dx minus u dv by dx. Okay, we use this formula here. So v square, and in numerator v du by dx minus u dv by dx. Again we get x plus 2y times 2 dy by dx minus 2x plus y times 1 2 times dy by dx. Then if when we take dy by dx outside of bracket, then we get x plus 2y minus 4x minus 2y. Here this 2x and this 2x will cancel, and the remaining part is 4y minus y is 3y. So we get dy by dx times minus 3x. Again, if we add these two terms, we get 3xy plus 6y square plus 6x square plus 3xy divided by x plus 2y whole cube. Then if we take 6 common, then we remaining x square plus xy plus y square, so which is 6a divided by x plus 2y whole cube. And then we get d square y plus divided by dx square plus 6a divided by x plus 2y whole cube is equal to 0. Okay, so proof now. Okay, now next part C. Equation of the given curve of the stem is x square plus xy plus y square equal to 0. This is equation 1. If a equal to 7, then we get x square plus xy plus y square equal to 7. Differentiating this both with respect to x, we get 2x plus x dy by dx plus y plus 2y dy by dx is equal to 0. Then we get dy by dx is equal to minus 2x plus y divided by x plus 2y. At this point, dy by dx will be minus 4 by 5. So equation of the tangent at this point will be y plus 2 is equal to minus 4 by 5 x plus 1. So tangent, equation of tangent is 4x plus 5y plus 14 is equal to 0. And equation of the normal at this point, y plus 2 times dy by dx, which is minus 4 by 5 plus x plus 1 is equal to 0. So now 5x minus 4y minus 3 is equal to 0. This is our normal equation of normal. Okay, so that's all for today. I hope this will problems will help you to understand the topic differentiation, and please tell me if you have problems in any specific topic. The HSC student and or intermediate student in Bangladesh, national curriculum or anywhere, if you have any problems in any topic, level and international curriculum student, Cambridge, Edexcel, just tell me. I will try to make video for you on that specific topic. Support my initiative and please subscribe my YouTube channel. Thank you everyone. Assalamu alaikum.